My name is Dave, and in this video I'm going to continue to talk about built-in data types, but this time we're going to look at the actual code. So I have a console app, and I recommend that you do this along with me, or watch it once through and then go back and do it along with me. So I have a console app. If you're not sure how to create a console app, I recommend the video on how to create a console app. So I have this console app. I've named mine basic data types. You can name yours whatever you like. And once you've done that, you want to open up program.cs. You just double click on this file, program.cs, in Solution Explorer. If you don't see Solution Explorer, you can always go to View and click on Solution Explorer. View Solution Explorer. So with console apps, you'll have this program.cs file. You just double click on that and it'll open this file. And you'll see this method called main. If you're not sure what a method is, don't sweat it. We'll talk about methods later. But you want to get in between these two curly brackets. Get in between these two curly brackets. These curly brackets denote a code block, right? Code block is just a block of statements, right? It's just a series of statements. So we want to get in between these open and close curly brackets. And so we're going to talk about built-in data types, and these are the data types that are just built in to C#. They're baked in, if you will. They're very basic. Some people call them primitive. They're called primitive data types. Just very, very basic data types that you use a lot. Most of these you use a lot. There are custom data types, which we'll talk about later. Custom types are created by teams at Microsoft, third parties. You can create your own custom data types. So we'll talk about custom types later. But we're going to focus on built-in, or the very basic primitive data types right now. And these are just very, very basic data types, right? So you can also think of these basic data types or primitive types as building blocks, because these types are used to build more complex custom data types. So one kind of data that C# represents is the whole number, right? The whole number. You got to be able to represent a whole number. Whole numbers are used for a lot of different things in coding. So, how would you represent the number 10 or the number 500 or the number 1 billion? How would you represent that? And the answer is you use whole number data types. And C# gives you several different options. Just going to focus on the main ones here. And the first one is called a byte. It's a byte data type. The byte data type. The byte holds a number from 0 to 255, so that's the range for the byte. So if you needed to hold the number 256, you would have to use another type. And let's see, I'm going to type in a variable here. If you don't know what a variable is, if you don't know what this equal sign is, don't sweat it. We're going to come back to that when we talk about variables. And so I'm going to just type in a number that's within the range of the byte data type. And let's go ahead and come back and talk about that in a minute. And I'm getting ahead of myself. Type the variable in first. Okay, so this is the short data type. And let's see. Okay, so these are the 4 data types for whole numbers that C# gives you. The first one is the byte data type. It's a byte data type. This is in the range of 0 to 255, and pretty much the only time you use a byte data type is if you're working with a binary. If you're working with binary data, as far as I know. So if you're not working with binary data, you're not working with bytes, then you're probably not going to use the byte data type. So as far as I know, that's the only use for it, is when you're working with binary data. The other one is the short data type. This is a data type I've never used, and it's one that you'll probably never use, but C# gives you, it is an option, so just want you to be aware of it. The one you will use a lot is the int, and this is probably the most used data type in C# or any language, is the int. This is an integer. It's a whole number. It's within the range, something like negative 2.1 billion to positive 2.1 billion, somewhere in that range. So that is the int data type. And the last one is the long data type. And this data type, you use this if you need a really long, really big number, like trillion or something like that. Okay, so you have four different data types for whole numbers, and you can think of these as ToGo Cups. So the byte would be, small, short would be medium, int, large, and the long, extra large, right? So you have small, medium, large, and extra large, and this has to do with space in the memory. Which type you use could depend on how much space you want to allocate in the memory. And this is, in some regard, this is kind of a throwback to the old days where you had very limited amount of memory space. Today, we have so much memory, it's not as much of an issue. But back in the day, you had to be very selective, very careful about how much memory you used. So you had different data types. If you only need a small number, a small amount of space, then you might use a byte. So that's the deal on that. But most of the time, you're just going to use an int. 99% of the time, unless you're working with binary data, then you might use a byte. But the int is, if you need a whole number, the int is almost certainly the way to go. Okay, so the byte, short, int, long, these are types, or data type. Type is short for data types, just means data types, right? And a lot of times in the documentation and different books, you'll see the word type or types, but it's just short for data types, right? So these are the data types. These are the types of data, right? The byte, short, int, long, and these four data types take whole numbers, sort of different sizes of whole numbers. Like I said, you can think of them as ToGo Cups. So these are the data types for whole numbers: byte, short, int, long. And again, int is the one you'll use 99% of the time. These numbers over here are literals. Literals. What I mean by literal is just the value that you typed in. These are values that I typed in, as opposed to values that came from a database or was a result of a calculation or something along there, or user input, as opposed to something like that. The literal is a value that you actually type in, that you hard code, that you type in. So these, we could call these like an int. This particular one, you can call it an int literal. And this one you could call a short literal, a byte literal, a long literal, if you will. So these are literals, right? Literal just means a value that you actually typed in, that you typed into the code, sort of hard coded, right? So that's all that means. So also I want to point out that the numbers only hold a certain range. So, for example, this byte data type only holds a range from 0 to 255. 0 to 255. So let's try to put in 256 and see what happens. And then it's barking at me, right? Constant value 256 cannot be converted to a byte. It's outside of that range. So let's change this to 255. And there we go. So that's okay. And the short, I think that holds a range some negative 32,000 to positive 32,000, something like that. So let's put in a number that's clearly above that. And it's bucking on it. It's too large, right? It's outside of its range. So they have to be within the range. If they're outside of the range for that data type, then it's like trying to pour a pound of sugar into a coffee cup, right? It's just too much data. The byte doesn't allocate enough space in the memory to hold a number above 255, right? So it only allocates a small amount of space. That's basically what we're talking about, is the allocation of space. The byte only allocates a small amount of space. The int allocates, a good size of space. The long allocates a lot of space, right? So that's why we can use the to-go cup analogy there. Or that's more technically what we're talking about when we say they're like to-go cups. So we have the four data types for whole numbers. But these are whole numbers. What about real numbers? Numbers with a decimal value. And C# gives you 3 data types to represent numbers with a decimal value, or real number. Okay, so I have 3 data types: the float, double, and decimal. Float, double, and decimal. And actually, I don't think a float is used that often in C#. Most of the time you use a double. That's the most common data type. And note too that with floats and the decimal, with a float you need this F. You need to suffix the literal number. This is a float literal, right? Just a literal. By literal just means the value typed in. But with float literals, or any with float literals, you have to suffix it with this F, this letter F, and it can be lowercase, uppercase, doesn't matter. So you have to suffix it with the F, so it knows that it's a float. C# will know it's a float instead of a double or a decimal. And same type of thing with the decimal. You have to suffix it with an M. And again, it'd be lowercase, uppercase, doesn't matter. But you have to suffix it with the letter M, and that way it knows it's a decimal as opposed to a double or a float, right? And note too, with doubles, you don't need to suffix it. You can suffix it with a D, capital D, uppercase, lowercase, doesn't matter. You can do that, but it's not necessary, because doubles, the double type is the default. That's the default data type for real numbers. And typically I never suffix a double literal with a D. It's not necessary. So with float literals, you need to suffix it with the letter F, and with decimal literals, you need to suffix it with an M. And by the way, M stands for money. And this is the type for if you're representing money. This is the type you use, the decimal. And again, this is like to-go cups. My float, this is a variable that's of type float, right? So the float type holds a real number, and it's accurate up to about 7 decimal places, something like that. And a double holds a real number, represents a real number that is accurate up to about 15 decimal places, right? And by the way, these are called floating point numbers. Floating point number. Float is short for floating point number. So double holds a decimal value, a number with a decimal value, a real number, and it's accurate up to about 15 decimal places. A decimal holds a number with a decimal value, and it's accurate up to about 28 decimal places. So the decimal is highly, highly accurate. So if you're creating financial software or scientific software, then the decimal is probably what you want to use. If you want that high level of accuracy. It's also a little slower than the double, and you're taking up more memory space. So if you don't need that kind of accuracy, a double is probably the way to go, or a float. But I believe double is the most common. That's the one I always use, and that's probably the most common type for a real number in C#. So those are data types for numbers, basic data types for numbers, but what about just plain text, just plain old text? And plain text, we call this a string. It's called a string, and technically it's a series or a string of Unicode characters, and we'll talk about Unicode later on. But you can think of it as just text, just plain Jane text, plain old text. It's probably the best way to think of it. And so that's the string data type, and this is just plain text, and strings have a lot of uses in computer programming. So as you can see, I have 3 variables, and again, if you don't know what a variable is, don't sweat it. We're going to talk about variables later on. And also, you probably notice this green squiggly line. This is just telling us that we've assigned these variables, but we haven't used them. So it's giving us a heads up. Visual Studio is giving us a heads up that we've got these variables, but we haven't used them. Okay, so it's telling us that we have these variables that we haven't used. So that's all that the green squiggly line. So we're going to ignore that because we're not going to use them here. So I have 3 variables that hold a string data type. And as you can see, this is just plain text over here. Also note that I have these quotes. For strings, you have to have these quotes. These are string literals, right? And again, literal is just the value that I've typed in. But these are string literals, and the literals have their own type, right? C# will recognize what type this is. If you type in a whole number, it's probably going to recognize it as an int. And if you type in a literal number with a suffix with an F, it's going to recognize it as the float type. But with strings, if it sees the quotation marks, it's going to recognize it as a string, right? This tells C# that this is a string. And if you hover over the string literal, you'll see that it's a string, right? It represents text as a series of Unicode characters. So it's of string type. That's the type of data it is, the data type. It's a string. And the way it knows that is with these quotation marks, right? That's what the quotation marks do. You have to have those quotation marks. If you don't have the quotation marks, it's going to buck, right? It's going to bark at you. So you have to have the quotation marks, and the quotation marks just say, this is a string. And note the color too, the sort of burgundy color here, that denotes that it's a string. And that's not part of C#, that's part of Visual Studio's syntax highlighting. Syntax highlighting, that's the visual cues to you, so it kind of lets you know what's going on. You know this is a string by the color. And then the built-in data types, they're all blue. All these keywords, these are keywords. This is a data type string. This is a keyword. These are keywords up here. And they're all blue. Blue indicates that it's built into C#. This is built in, it's baked into C#, right? So that's what anytime you see blue in Visual Studio, you know that's built into C#, as opposed to this, which is not built into C#. This is actually a custom type, and we'll talk about those later on. So that's what the burgundy color represents. It's a string. That's what it indicates. And string literals have to have quotation marks. A string literal has to have these quotation marks, and the double quotes, not the single quotes. So this is the string type, essentially just plain text. We also have the char type that represents plain text, but just one character. And it's the A. So this is the char data type, and this is for one character, just one character. If you try to put more than one character, it's going to bark at you. So it's only for one character, right? And note too, if I let's change this to single quotes. The char takes single quotation marks. You gotta have the single quotation marks for chars. And let's see, if I try to use single quotes here for this string literal, you see it's barking at me and it's saying too many characters in character literal. So it's seeing it as a char data type, right, because of the single quotes. So it says, well, this is a char. It's got the single quotation marks. So that means this is a char, but there's too many characters for it to be a char. You can only have one character for a char. Excuse me, for a char. So let's change this back to double quotes. And now it sees it as a string again, and it's okay for a string. A string can have as many characters as you need. But a char can only take one character. So if you know you only need one character, then a char might be the way to go. It's going to take up less space in the computer's memory. Okay, so just one more data type. And this is a very simple data type. This is bool, which is short for Boolean, right? Short for Boolean. Alright, so the bool data type, bool is short for Boolean. Boolean just means true or false. That's all. These are the only two possible values that a bool type can have. You try to give it a string, it's going to buck on you, right? You get the red squiggly lines, and it's going to buck on that. Try to give it a number, it's going to buck on that. So the only thing you can put in here is true or false. It's got to be lowercase t, right? Try an uppercase, it's going to bark. So lowercase t, lowercase f. So bool data type takes a value of either true or false. It's got to be true or false, one or the other. There's not a lot of gray area in computer programming. Something's either true or it's false. And a lot of times you need to hold that value. So a bool is something that you use quite a bit in programming. Ints, ints, strings, doubles, bool, these are probably the most common data types in programming. And they're types that you're going to use a lot. So all of these are very basic built-in data types. There are a lot of data types out there, especially when we get to the .NET class library. There are thousands of custom types, and you can think of these basic types as building blocks, because all of those custom types, no matter how complex they are, use these basic types. You're going to, if you look inside a custom type, you're probably going to see some int variables, some double variables. You're going to see strings, bools. So these are like the building blocks, if you will. So these are very basic data types, and all these types are built in to C#. So these are the built-in, baked-in, primitive, some people call them, just very basic data types that come with C#. So these are basic built-in data types.